This is the second video for the first part of SLO 3. Last time we looked at various charts and graphs for qualitative data. Today we're going to look at charts and especially graphs for quantitative data. In particular, histograms. Graphs of frequency distributions with, as I said, quantitative variables. For example, if we're given a big table of data, right? In this case, it's prices in thousands for base models of BMWs. Let's see if we can illustrate this in a meaningful way. So first what we're going to do is we're going to use a frequency distribution. Now, unlike last time, this is going to be for quantitative data. And I've gone ahead and done it, and I will now paste it right over here, just in the interest of saving time. Okay? Now, note that this is exactly the same as a frequency distribution. For qualitative data, the one difference is that we have classes instead of categories. Qualitative, except with classes instead of categories. Right? We see classes is highlighted in yellow, right? So what we're going to do is we're going to use this table to then draw a graph. I'll do the graph on the next page, though. Before we draw the graph, let's discuss what it actually is. A histogram is a graph used to illustrate a frequency distribution. It could also be a relative frequency distribution. What frequency distribution? It's like a bar graph, except the x-axis is, of course, quantitative. And also the bars are touching. Okay? They're touching each other. Remember, the bar graph, they did not touch each other. Now, the lower class limit and the upper class limit are just the lowest and highest values of the bars, basically. Right, or of a class, so to speak, right? The class width, you might guess, is the following. The class width is going to equal the lower class limit the upper class limit minus the lower Note that all classes have the same width. And usually we want between 5 and 20 classes in a histogram. This isn't some kind of rule, but unless the data set is very large, it's just not super pleasant to look at a histogram with too many classes. And it's not very meaningful to look at a histogram with too few classes. So how to create one? How do we create one? Well, first we choose a lower class limit for the lowest class. And this should usually be not so bad, right? Like in the case of this data, we look at the lowest value, and it looks like it's 35.3. So probably a good lower class. I mean, you could say 35, but I would just say 30, right? A nice easy number like that. Then choose an upper class limit for the lowest class. And this, you run into a little bit of decision making here, right? I could have chosen 39.9, right? To effectively make the class width 9.9 or about 10. But it turns out that that just doesn't produce as nice a graph as if you make it 20. So there's a little bit of maybe guesswork or just trial and error. If you use Minitab, by the way, it just automatically comes up with the best looking graph. So that's kind of nice. Anyway, then you, of course, compute the class width, right, with that little formula above. I guess if you do it for one class, you do it for all classes, and then you use a frequency chart or a relative frequency chart, I guess I'll call it distribution, to draw the graph. Okay, so let's draw it real quick. Now, I actually have it illustrated right here. Let us just borrow this. And copy it, and maybe stick it right here. Oh, and of course, we'll need to rotate that a little bit. And maybe drag it back down here, right? Make it nice and big. Nice and big. Okay. That is our that is our histogram, right? Notice that it's like a bar graph, except the bars are touching. Also notice, of course, that the classes are numerical, right, quantitative. But notice also that the frequency is still the y-axis, right? And the classes or categories are still the x-axis, okay? So that's how you create a histogram. Now, just to let you know, most of the time in this class, we'll be using Minitab or some other graphical software to create a histogram. But it is good to be able to create one by hand, just basically. All right. Now, just to let you know, histograms for discrete data are analogous, except that in this case, data classes may be a single value. Right. Now, I don't think we have that in this case. In example 2, I would recommend using 2 values per class. But still, you know, there could be another situation where a class could be a single value, right? So maybe I could start this one and maybe let you finish it, right? So the first thing that you want to do when you have a data and you want to create a histogram, you construct a frequency histogram or a relative frequency histogram, right? So just in the interest of time, I'm going to go ahead and borrow that. I'll borrow this right here. Copy that. And I guess I'll paste it right here. So for part A, to construct a relative or frequency or relative frequency distribution, it would look something like that. Okay? Note that this is the frequency chart, and then this is the relative frequency chart, right? So we've got that. Okay? So this right here, maybe I'll use red just to emphasize it. This right here is parts A and B. And of course, if you want to pause the video and, you know, just verify this for yourself, then you can. Right? There's your data. And then, of course, we will actually need to create a histogram. So again, just in the interest of time, we'll go ahead and do this. There we go. Right, so if you look at the black ink, that's a relative frequency distribution or relative frequency histogram. If you look at just the red ink, it's a frequency histogram, no relative, right? Okay, and just note the shape of it, right? What would you say about the shape of it? Well, notice that it seems to be increasing, and then it drops off suddenly, right? Those two values right there are pretty low, okay? And there is a word for that. The histograms are skewed to the right. Okay, and we'll discuss what that term means in a sec. Right? In general, what do we notice about the shape of the histograms we've drawn? Well, we've got a couple of different things going on. As we just mentioned, we could have skewness, right? I'll just write over here, skew is another word for tail. So maybe I'll say skew to the right or left means a small amount of data appears to the right or left of the rest. And here's an example, right? I can define a term, but I think it's best if we just have an example. Right? So we could have something like this, right? Where our data, looks pretty good, whatever, looks pretty normal-ish, whatever, doing our stuff. Maybe it goes here, whatever. And then all of a sudden we've got some data out there. That's skew to the right. Or you could say skew to the right or skewed right. Right? And then, of course, left is the opposite, right? You have something like this, something we call an outlier, right? Maybe something else like that, whatever, right? That's skewed left. Right. Okay. So there's that. There are measures of skewness, by the way, like what's technically skewed. Just use your eye, right? Just use the eye test, right? What do we also have? We also have symmetry, right? Right? And I think we probably know what that means, right? If it's, well, identical shaped, I guess I'd say, to the right or left of the center. I guess you could say if it's reflected about the center, right? So here are a couple of examples, right? You could have a graph. This is a pretty standard shape we see right here. Right? It's just completely symmetric, right? You also could have something that you also see. Maybe something like this. And it kind of goes down a little bit, but it still actually is symmetric, right? Because it does reflect. Right? Something like that, right? Again, symmetric. A graph is bimodal. This is an important one. If, well, bi means two, mode means most. And you would say if it rises, falls, and then rises again. Right, and here's a quick example of this. Maybe I'll stick the example over here. Right, so for example, we're rising, oh, we rise, and then all of a sudden we fall a bit. And then all of a sudden, oh, we get bigger again. See how the graph right here dipped a bit? That right there is bimodal. Right, and last but not least, maybe I'll just put it right here. A graph is uniform if all bars have the same value or height. So here's an example of that. kind of a boring example, right? Just right there. They're all the same height, right? Uniform. All right. And last but not least, we can draw line graphs called frequency polygons by constructing a histogram, finding the midpoint of each class, and then graphing a point for each midpoint with a line in between. So relative frequency polygon, for example, 1. For example, well, here's an example with slightly different data classes. Right? If you want to try it with the original data classes, then feel free to do so. Be a good little exercise. And then last but not least, a frequency ogive. Yeah, I'd never heard of this either. It's like a frequency polygon, except ogive plots increase. Right? Or I should say rather, sorry, it plots cumulative relative frequencies. And again, I'll just do a quick illustration. It's just this. I don't want to spend too much time on this. It's not super common or important, but just so you see it, just in case it ever comes up. All right, that's what you got. All right, and that's all for this video.